Welcome to day 7 of our part 2 statistics unit. Today, our goal, given a set of bivariate data, you will be able to determine the line or curve of best fit, find its equation, and use its equation to make future predictions. Make sure you've got your calculator handy. All right, so how are we going to accomplish this goal? Well, step number 1, you need to make sure that you look at the data and determine if it appears to be linear, quadratic, or exponential. Step number 2, plot the data to confirm your observations. Step 3, complete a regression to find the line of best fit or the curve of best fit. And step 4, use the equation to predict future values. Okay, so let's go ahead and take a look at our very first set of data. Below is the set of data that about temperatures outside with the number of popsicles sold from a traveling ice cream truck. So here we have the temperatures. Here we have the popsicles sold. So let's take a look. Our temperatures, okay, are continuously going up, 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 and up. So let's take a look at what happens with the popsicles. So we go 35, 51, 62, 70. So they're going up, 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 up. But then look what happens. It goes back down, 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 down. So we're increasing and then we're decreasing. So what type of a relationship does the data appear to be? Linear, quadratic, or exponential? And why did you select your choice? I am going to pick quadratic. And I'm going to say that the data is quadratic because the y values increase and then decrease, making this a quadratic function. So they're going to increase and then decrease as your x values continue to go up. All right, so now step number 2, we have to make sure that we plot the data to confirm our observations. So let's go ahead, we need to plot this data. So temperature is my independent, so that's going to be my x value. Okay, and popsicles sold is going to be my y value. Okay, now if I take a look at my x values, I'm starting at 57 and I'm going all the way up to 102. So I definitely don't want to start my graph right at 0. So I'm going to put in a break and then I'm going to start my data at 50. Now, if I have to go all the way up to 102 degrees, I'm going to have to definitely count by something higher than 1s. I'm going to go ahead and count by 5s. So 55, 60. 65, 70. And we're going to go all the way up to 105. Okay, now I'm going to take a look at my popsicle sold. My lowest popsicle sold is 35. My highest is 80. All right, so because of that, I'm again going to put in a break for my y values. And I'm going to start my popsicle sales at 30. Now I have to get all the way up to 80, which is a pretty big range. So I'm going to once again count by 5s. And I have to make sure I go all the way up to 80 because that's my maximum. Okay, now that I have my scales for my x and my y, I can go ahead and plot my points. 57, 35, so a little past 55 and all the way up to 35. 64 and 51. So go ahead now, pause the video, and I'd like you to finish plotting all of your points. Okay, so if we take a look at the data that we have plotted, it goes up and then it goes back down, which just confirms that it is going to be a quadratic curve of best fit. All right, so let's go ahead. So part B. What is the equation of the line or curve of best fit? Round all values to the nearest hundredth. Okay, so I'm going to let my calculator do the work for me here. So I'm going to go ahead and go to Stat, Edit, input my temperatures in L1, my popsicles sold in L2. I already have those there. All right, now I'm going to go over to Stat, Calculate, and I'm going to go down to choice 5, Quadratic Regression. And now I'm going to go ahead and it says round all values to the nearest hundredth. Okay, so the nearest hundredth. So my A value is going to be negative 0.07. My B value is going to be 10.96. And my C value is going to be negative 364.25. Okay, so now I'm going to go ahead and put that into the equation. So y equals negative 0.07 x squared plus 10.96x minus, this time it is a minus because the C is negative, 364.25. And now we have our curve of best fit. Now that we have the curve of best fit, we can use it to predict future outcomes. So let's take a look at part C. If the temperature for Saturday is supposed to be 82 degrees, how many popsicles should the ice cream truck plan on selling? So 82 degrees, so if I take a look back at my values, 82 is temperature. That's my X value. So I'm going to start by writing my equation. Okay, and now I'm going to go ahead and substitute 82 wherever I see an X value. So here's my first X. I'm going to plug in 82, and that's going to be squared plus 10.96. Again, this is going to be 82 for my X minus 364.25. Okay, now I'm going to let the calculator do the work for me. So I'm going to go ahead and just type it in. So negative 0.07 in parentheses 82 squared plus 10.96 in parentheses 82 minus 364.25. Enter. All right, and I get y is equal to 96.67. So how many popsicles should the ice cream truck plan on selling? 97 popsicles. All right. Let's go ahead. Let's take a look now at our second set of data. Okay, below is the set of data that measures arm span and height. So let's take a look, arm span and height. So if we take a look at arm span, our independent are X values. We're going 155, 165, 180, 195, 170, 157, 190. So my X values are not always increasing or decreasing. They're kind of mixed up there. So before I answer part A, what type of relationship does it appear to be? I'm going to graph this first. So that way I know for sure what it is. So we have arm span for our X values and height for our Y values. So let's take a look at our X values first. Okay, we go from 155 seems to be our lowest and 190 is our highest. So I'm going to put a break in here and I'm going to start my values at 150 and I'm going to count by fives. 160, 165. Okay, now I'm going to take a look at height. My lowest value appears to be 150. My highest is 200. So once again, I'm going to put in a break. I'm going to start at 150, and I'm going to count by fives again. Okay, now I can go ahead and plot my data. 155 and 150. There's my first point. All right, go ahead, pause the video and finish completing your graph. Okay, so now that we have all of our data points plotted on our graph, I can see there seems to be a pattern, and it looks like as arm span increases, the height increases. This looks like it is a positive linear correlation. So what type of relationship does the data appear to be? I'm going to say it's linear. Okay, why did I select my choice? Because, oops, as x increases, the y increases. Or you could say the data follows a positive linear correlation. Okay, so now part B. What is the equation of this line or curve of best fit? Well, in fact, we just found that it is a line. So we're going to go ahead, put all of the data in our calculator, stat, edit. I already have all the data there, so now I'm going to go stat, calculate, and I'm going to go down to choice 4, linear regression. All right, it says round all values to the nearest hundredth. So my A is going to be 0.93. My B is going to be 14.74. So when I write my equation, it's y equals 0.93x plus 14.74. All right, so now that I have my line, actually, let's go one step further. Everybody take a look at your R value, 0.91. Is that a strong or a weak? That's definitely a strong linear correlation because the R value is very close to 1. All right, so now let's use this equation to help us predict future values. So if an arm span is 150 centimeters, what is the predicted height? All right, so 100 arm span is 150. So let's go back up to our table. Arm span was our x. Height is our y. So since this says arm span, this is our x value. So I'm going to write down my equation. And now I'm going to go ahead and I'm going to write it, and I'm going to substitute in my x value of 150. And then everything's on one side of the equation, so I can type this right into the calculator. 0.93, 150 plus 14.74. So my y is going to be 154.2 because it says to the nearest tenth. And that's going to be my height in our, oops, not inches. Our units are centimeters. And now we know what our height is. So this is going to be height. All right, let's take a look at our next example. If a height is 184 centimeters is measured, what is the predicted arm span? So this time they're giving us the height is 184. So let's go back up and let's look carefully. Height was the y value. So this 184 is actually equal to our y value. So I'm going to go ahead, I'm going to rewrite my equation. Okay, and now I'm going to rewrite it, and I'm going to type in 184 for my y value. So 184 equals 0.93x plus 14.74. So now I have to solve for the x. So I'm going to transpose the 14.74 to the other side. So since it's adding, I'm now going to subtract. All right, so 184 minus 14.74, 169.26 equals 0.93x. So now I have to get the x by itself. So this 0.93 is being multiplied, so now I'm going to divide. So I'm going to take this answer, I'm going to divide it by 0.93. And y, or, sorry, this is not y, this is x is equal to 182 centimeters. And this is going to be the arm span. So ladies and gentlemen, it is very important that you not only look at the data, but you look at the graph to make sure that you know for sure what type of a relationship the data has before you figure out the line or the curve of best fit, and then use that to predict your values. All